Hi. Hi. Hello. Hi. I'm Tutti, and I'm from Mercari, but I'm going to go through a self-introduction really soon. So, thank you for coming for this talk. Today, I'm going to talk about scaling software development, about teams and Codebase. When you go from a small project into a bigger, more complex system, and your team is growing as well, what are the kind of things that you should go over to make sure you scale with efficiency? Okay, so my name is Tutti. I go by TuttiQ online on Twitter and GitHub and everything. I'm originally from Brazil, São Paulo, but I've already been to a few different countries working, including UK and now Tokyo in Japan. I'm a computer engineering major, so I majored in computer engineering back in Brazil and worked as a software engineer since 2011. I was working mainly with full stack web development and a little bit of mobile. And now, currently, I'm an engineering manager at Mercari and director of Women Who Code Tokyo. So being a director of Women Who Code Tokyo, I'm very, very happy to see this conference happening. I'm part of the organizing committee as well. And all the volunteers and everyone puts so much work into making this happen. I just want to say that this is an amazing job from all the volunteers, and I'm really happy that this is happening. And yeah, at Women Who Code Tokyo, this is how we gather. Just kidding. This is obviously a joke, but sometimes we do have pizza on our volunteers meetings. But of course, people are very motivated to have those activities. And Mercari is a big sponsor of Women Who Code, actually. So if you don't know Mercari, Mercari is a selling app. It's very, very famous in Japan, not so famous outside Japan, and expanded to the US recently as well. And like I said, big sponsor of Women Who Code Tokyo. We have many events there in the company, and they sponsor us with a venue and food and a bunch of volunteers to help us as well. Oops. Go back. No. There we go. So a little bit of my trajectory. So I started in Brazil. I moved to London as a software engineer at the time. I was working with Ruby on Rails in an e-learning startup that started expanding internationally as well. And then I moved to Tokyo in a big Japanese corporation, and now at Mercari, that is about 1,800 people company, so almost 2,000. I worked in startups that had like 15 people to multinational corporations like Bosch and Samsung as well, with more than like 400,000 employees. And my teams, I had teams that were just as small as you can imagine, like 3 people, and big ones like 13 or even more members. And I also worked developing from very simple web page applications to very complex multi-app platforms throughout my career. So just to give some perspective where I'm coming from with the stuff that I'm going to say today. And the software that I built software for 6 people. That was the first software that I built for a very small office through millions of users. Like Mercari, for example, has more than 10 million users in Japan. And I want to go through a disclaimer before I go through this talk, because this talk has very controversial topics. So what it means is that I'm going to talk about team structures that can be very different from company to company. I'm going to talk about development process that can be very different from team to team. Sometimes you don't even have to change the company to have a very completely different development process. Code readability, that is very subjective. And design patterns or best practice. What are best practice anyways? But I'm going to go over that. And a lot of the content is opinion-based, of course, and subjective to exceptions or counter-arguments. Please do raise your counter-arguments. Let's have a discussion at the end. That would be very fun. If you want to get those slides, you can scan this QR code, and you can follow the slides on your phone or anything. Are we good to go? Okay. So moving forward now, when you start working on a software project, right at the beginning, you write your code, you make your commits and changes, and you push to your repo, I hope. Then you deploy to your servers, and then you have a live web application, as simple as that. Of course not, but of course this would be a very simple process if you're working alone or with a friend in a very small project. This could be your process, yes. But let's add some complexity to this situation. So I have there my project that I'm working on. I have a few files, as you can see, like an index, some menus, some pages. And wait a moment, like I'm already like not following any standards or processes, and I already have two files called menu and menu2. What's the difference between them? Well, I don't know because I didn't name them properly. So that's one problem. And then let's say I start working on a new feature that is called search. So I create this file, search.js, and I'm going to start working on it. But my coworker, Maria, also started working on a different feature called item search. So she decided to create a file called item search. Now we have search logic distributed in two different files. Things are starting to get a little bit messy. And this is a very small example in a very small project. But if you scale the problem, you go to a huge code base where you cannot find anything because everyone is like working without proper communication, without proper standards, without following a process, and we have redundancy, we have bugs being inserted, we have conflicts and inconsistencies across the whole code base. And where am I? I'm here, me. I'm very confused. I don't even know where to start because this is a mess. And yes, my team is the whole cast of friends. They're very good programmers. Yeah, so that's very complicated. And can you imagine like all the overhead that this is causing, like all the problems that it's introducing, and the onboarding time on this code base? It's ridiculously high. So we have a problem snowball here. We have an unstable system. We have the complexity that keeps increasing. We have high stress on all the developers and low productivity, which is the worst scenario ever. Because if you have stress but you're producing a lot, could be justified. But if you're stressed and you're not being productive, that is the worst case scenario. And you have the technical debt building up and a long time to ramp up new developers. So how do we scale efficiently? So I'm going to go over each one of those topics. And the first one is like reducing the knowledge sharing bottleneck. So basically making things easier to understand right at a glance. When you look at it, you don't have too much explanation. You don't have someone that has all the knowledge in their head, and you have to go to that person all the time. So that would be organizing your code so it's very intuitive and easy to understand. Documenting as well. The other part is quality assurance. Quality assurance is very important to scale because if you want to ship faster, you got to be confident that you're not introducing new bugs every time that you push a new feature. May sound very, very obvious for engineers, but automation of repetitive tasks. Automate everything that you can so you don't waste time with tasks that don't bring much value. And structured teams and processes. Okay, let's go over those. So starting with the organized and intuitive code base, there are a few ways to do that. We can go over system design, how you organize your code base, a style guide, having rules on how to code, and best practices. Have anyone ever had this discussion? Spaces versus tabs. Classic, right? Okay, let's talk about system design. So the basic idea of system design are design patterns. Design patterns are ways to split your code into smaller parts. So it's easier to understand what part is doing what. You have more defined responsibilities, and you have well-known patterns across the industry that you don't need to onboard anyone on them. So if your developers already know the industry standard patterns, you cut your onboarding time. And it's also easier to find learning resources if they don't know, because it's all on the internet already. So for example, a very, very common one, MVC. Who heard of MVC? Okay, fair amount of people, good. So MVC is Model View Controller. So this is just one of many design patterns where you split your code into data kind of layer, the models that will represent the entities or the data of your system, your views that will represent the interaction with the user, the visible part, the UI, and the controllers that are basically your router. They will do the connection between the models and the views, basically triggering behaviors on the models or getting data from the models and handling the requests from the views. So this is already a good way to start organizing your code, right? Very basic MVC. And you can organize your code base into your folders like that. This is a Rails example, Ruby on Rails example. But sometimes MVC is not enough. When your code base gets really, really large, you have to go a little bit further. You start getting really what we call fat components, that are files that have really a lot of lines that are really, really big. Fat controllers, fat models, too much logic in one place. It's hard to see the code snippet here, but this is a controller, and it has a lot of logic in a controller that could not be there. For example, the error handling, all the translations, there's some stuff that could be extracted somewhere. Handling of parameters and parsing data. This kind of thing does not necessarily has to be in this controller. The controller could be just responsible for, like, you want this view, I'm going to get this data and give you this view. Very simple. But, oops. Yeah, so the problems of fat controllers. It's really hard to find the logic when you're looking at the file structure, because if you have too much logic in one file, you cannot have like a name of a file that will describe everything that you're doing there. So it's going to be hard to find. It's going to be harder to read and understand what a component does, because you have to go through like too many lines to find where things are. Your components become very specific. If they're doing too much, it's really hard to reuse that component because it's very specific. And it's harder to break the app into separate modules. That is kind of a consequence of being too specific. And being harder to break the app in separate modules can become even a bigger problem if you want to split your infrastructure later on. And it's harder to unit test, which means testing each part. If you have too much logic in it, you are actually testing several different things and not only one. It's not a unit test anymore. So those are some of the problems. And oops. So the first advice, like at some point, sometime in the past, I don't remember when, there was a very popular saying, that was keep your controllers skinny and make your models fat, because the models should have all the business logic. So your controllers are only responsible for routing, but what happens is that we end up with skinny controllers and obese models. Like this model here is a real example that I had in my experience. There was a user model with more than 700 lines. Can you imagine how much logic was there? Too much, way too much. So there are actually ways to extract logic. Sorry. There are ways to extract logic, and one way that you're going to hear as well is mixins. So mixins is a practice where you pull out sets of methods or functions into a separate file, and then you include this file in other files. Kind of like similar to an interface. But if you don't do it properly, the analogy here is that you're getting a really messy room and just putting this stuff randomly into messy drawers. On the outside, it looks great. Your model is going to look very skinny, but then you're including a bunch of mess into it, and you still cannot find anything. So you got to be very careful with mixins, because if you don't do them properly, you're not organizing your code. You're just hiding the mess, making it harder to find. So there are problems to extract logic. So mixins when they're properly implemented, of course. So for example, let's go with the user authenticator here. So this was a class that we created just to handle authentication logic. So we get usernames, we get passwords, we do whatever hashing we have to do, we check if the user exists, we reset passwords. All the authentication logic was extracted into an authenticator service module. And then we anywhere we wanted. Value objects, for example, it's basic concept of object-oriented programming. You start breaking your objects into smaller objects. So instead of having 3 or 4 attributes that represent a color, a gradient, something to change, a method to change the color, you just extract everything into a value object. So things like that. There are service objects, policy objects. There are many ways. I'm not going to go over all of those because this is actually a separate talk that I have. It's called Refactoring Fat Components. So if you want to check those slides, you can scan this QR code. Okay, I'm going to give you a second. Yeah. So refactoring fat components is a good way to organize your code. And do you see where I'm going here with breaking things into modules and smaller pieces and organizing and separating, decoupling? So the next step, if your system gets really, really large, is to go into infrastructure or architecture. That is splitting your big system into smaller services that are responsible for smaller things. And then you connect all of them. And there's a bunch of challenges with the microservices approach. So this is a microservices approach. There are many challenges with this approach, but it's very hot nowadays. A lot of companies are doing. Whole other talk on microservices, but I'm not doing that today. Okay, moving forward, coding style guide. So now that your code is properly organized into modules and nice classes and everything, we go into coding style guide. Why do we want a coding style guide? Because we want to avoid inconsistencies in the code format, because they make the development inefficient. What do I mean by that? If you look at the code and you cannot figure out exactly how you should write it, like should I use the camel case, should I use snake case, should I have a sample number, a variable, or a constant? I don't know because I didn't like differentiate between constants and variables in my code base. So everything becomes one step slower. It's small, but a lot of small steps slower, you get very, very slower, right? So is this code inside this method a class, a block? Is just an indentation inconsistency? Could be. So coding style guide is to solve those kind of small formatting problems and set a standard that everyone follows. And there are many public style guides out there that you can choose one and follow. You don't have to create one from scratch. This, for example, is the Google HTML and CSS style guide. It's public. And they have rules like, for example, indent by 2 spaces at a time that just tell everyone, don't do anything different than that, please. And this is the Ruby style guide, for example, that has rules like avoid single line methods. And style guides, they're funny because there's not right or wrong. It's just like, we chose that. It's just like, we chose. So you choose if you want your bed on this side of the room or that side of the room, but you just choose, right? And then everyone follows. So you can find those online. And best practices. Best practices are, again, like very debatable, but things that across the industry, people will start following those kind of standards. So it's easier for everyone to speak the same language. For example, the single responsibility principle. So the single responsibility principle says that a class or a method or a component should have only one responsibility. If it has more than one, it's doing two. Class. And this is a principle that guides you to have organized code, so you don't end up with the mess in the first place. If you have people that know those principles and follow them, it's easier for everyone. And dry, don't repeat yourself. I like this one very much. If you're copying and pasting code, changing very little, you could probably extract this to a reusable component, module, or function. So don't copy and paste everywhere. That's not a good practice. It's not code reuse. Or it's bad code reuse, I guess. And there are many, many others. I like the Boy Scout rule as well that says leave the campground cleaner than you found it, which means you're going through the code and you see something messy. Oh, this looks a bit weird. Well, just clean it. If it's small, clean it and just do your part, you know. Leave it better than you found. Of course, don't go into refactoring the whole code, because that would be problematic. And avoid premature optimization. Keep it simple to avoid over-engineering, that kind of problem. Oops. This clicker is very sensitive. Documentation. OK. The next step to having an intuitive code base is to actually have documentation. And there are several ways that you can do that. One is having code annotation, like this one's. You have, for example, writing on top of your method, you say exactly what this method does. Given a user, a password, checks if the password is correct or whatever. So that's very easy for someone who jumps into your code base and is like, oh, OK, I know what this method does. And you're going to hear people that say, if your code is really good, you don't have to make comments, because your code is really easy to read. So your documentation is your code base. That's a very ideal, pink-colored world that I don't live in. In my experience, small comments for things that are not obvious are always helpful. Of course, we're not saying you have to comment every single line that you code. So just find a balance, right? Everything in life is about balance. And for example, there are annotations like this, deprecated method, that kind of thing. And there are some tools that you can use that will transform annotations into warnings on your IDE or into error messages if you do something that your annotation is telling you not to. There is another way that is like this that I've seen as well, where you have a class that does something like notifiable is an interface to implement a notification behavior on every component that you edit. And here you have on top of the class a huge block of comments explaining how to use the class. This is another type of code annotation. To be honest, this kind I'm not a big fan of, because this is like kind of a more complete documentation that should not be hidden in the code. It should be easier to find somewhere else where you have actually good like search engine, or you have a menu that you can navigate through, something like that, because this is very hidden. You have to open the file to find it. So there are other things like this, for example, where you put some annotations in your code, but then you can run a tool, like a library or something, that will generate a user-friendly interface for your documentation, right? So this makes it a lot easier to navigate this, find how your code works. And of course, there's human-made wiki that sometimes is necessary. So we like to have them. This is the wiki for the Mercari microservices onboarding. So when someone new joins, they can go through this documentation and know how to set up their environment, how things work, etc. So this is also valid and very useful type of documentation. QA. Let's go into quality assurance. So tests. Again, you need to make sure that you can ship stuff without breaking everything. And that's where we go into unit and integration tests. You have the confidence that you can do that big refactor that you wanted to do, and all your tests are passing. You say, okay, this is good to go. So you're not afraid of doing big changes like that. But then again, your tests have to be reliable. So you have to have a really nice test coverage with really useful tests that are testing the critical parts of your system, so you can trust them. So if you can trust your test suite, then you can make your changes and be sure that they're not going to destroy everything. This increases the efficiency very much. And monitoring real-time problems. There are several tools, like this one, for example, is called New Relic. Everyone heard of New Relic here? Okay, good amount of people. So yeah, it monitors real-time your servers and can give you many warnings if something goes really wrong. So if you do ship something that breaks everything, you're going to know very fast. So that there's a way for you to just revert. Like, oops, roll back. Can't do that. And we'll monitor a lot of things like how many requests you're having on your APIs, or how many access to the database, something like that, that could break your system, how many exceptions you're getting from each type. It's a very useful tool. There we go. And automation of repetitive tasks. So there's a lot, right? So why not? One of them is continuous integration and continuous delivery. So there are tools out there like Circle CI or Jenkins. Don't you love the angry Jenkins? It's funny because if you go into jenkins.io.artwork, you can find only like parodies of the Jenkins mascot. It's so funny. People have so much free time. I love it. So yeah, so tools like Jenkins and Circle CI that will automate your testing process and your release process. So continuous integration is you make sure that you run all of your tests whenever either you push a new PR or when you're merging a PR into your production branch or something. You can run all your tests, and it can let you know, like, oh, this actually is going to break a few tests, so you should not do that or something. So very useful tool. You can have workflows step by step automation in there, including the continuous delivery, that is automated releases. Suppose you merge something to your master branch, you want it to be released to production, to deploy into your production server right away. You can set up that, so you don't have to do manually all the time. And of course, linters and safety checkers. So remember when we talked about code style guide? How would it be if we had to manually check all the 2 spaces? Did you give 2 spaces here? Is this a tab? That would be really, really annoying. So we don't have to do that, luckily. We have linters and other tools that can help us identify all those formatting problems, and even more sophisticated problems. There are linters that can even recognize like memory leaks situations, or null pointer exceptions, those kind of things. They're really advanced. And they can give you a warning even before you commit to your branch. So that's very useful. Yeah. Oops. Why is that happening? So many. There we go. So now let's talk about structured teams and processes. And okay, so we have, of course, a big problem on the people side as well, is not only on the code side. And everyone touching the same code base can be very messy. Everyone discussing the same domain can have very redundant discussions happening at the same time. And everyone working across all technologies and business logic. This can be very exhausting for our engineers to work across the full stack. They have to like maintain a lot of context, right? And the lack of boundaries and roles, it's just messy. Like we're all doing the same thing. So we have to define some rules for that. So for example, we can start with team structures. So teams with more than 5 to 6 people tend to organically split into smaller groups. This is not a research. This is not like a well-credited source. It's my experience. But I've seen that in many different places where you have big teams, they tend to group into smaller parties. And you have the people that are more close to each other and the people that are not. And it's not very fun, I can say. So, and the one thing that you have is when you have a lot of people in a team or in a meeting room, you have people having insecurities about sharing things with everyone. And you have too much context from too many sides for everyone to absorb. You can never keep track of everyone is doing. So smaller teams are better in general. And meetings with more than 5 to 6 people tend to have a maximum of 2 to 3 active participants. The rest, they're all just listening or doing work during the meeting or browsing Twitter. But they're not actively participating in the meeting. So it never works to have a meeting with a bunch of people, unless it is kind of a one-way presentation kind of thing. But again, because of the similar reasons, they have insecurities about speaking in front of everyone. Who doesn't, right? And it's hard to find a break to jump into the conversation when you have too many people speaking. And it takes longer to reach any conclusion, because you're almost getting to the conclusion and then someone jumps in like, what about that other case? You know, and then you start over and over, and then someone brings the same opinion because they were not paying attention. Remember, they were on Twitter. So they came back and like bring the same point that you already discussed. I was like, oh God, this is never gonna end. So yeah, keep your meetings with small. And processes and standards that everyone follow. So we talked about the tools, but getting an agreement from your team on how are you going to handle PRs, how are you going to handle the tickets or the documentation. Is it going to be distributed? You're going to have someone in charge? You're going to rotate the role? However the rule you decide. There's no right or wrong. Just decide a rule. Project or sprint cycle as well. So then here it goes, depending on the project management methodology that you're using. You could be using Agile, Waterfall, doesn't matter. Just have a process, have a rule, have defined cycles. Define roles and tasks that everyone should do. Who is in charge of code cleanup? Hopefully everyone. Code review. Have a rule for code review. I've been to places where we would like choose whoever is going to review your code. I've been to places where we would be random selection, so from a pool of engineers. And I've been to places where we had code owners from different parts of the code. You have someone who has more experience, and then you have to ask them for review. Just have a rule that things can be smooth. And who's going to be in charge of releases if it's not automated, if it's a rotation or whatever. Task assignment strategy. Is it self-assigned? You go and like pick a task that you want to work on, or is the manager assigning, or the PO, or whoever? Just have those things defined, and things will flow a lot easier. And structuring your teams. I've also seen different ways of structuring teams. For example, in some companies you have temporary teams that will work on a project together, and then the project finishes, and then disband the team, and they go into a different project. That's one approach. Or you can have more long-term teams that are in charge of a business domain. For example, if you can have a team that is in charge of your shopping cart feature, and they're going to do all the projects that are related to the shopping cart, renovating the cart, anything around that. They stay on that business domain. Well too. And that is a good way to map your team into microservices. Remember when I was saying about splitting your system into smaller systems? A good way to go about it is to have a team in charge of a microservices or multiple microservices, and have them in charge of that part and not moving them around too much. So that's a good way to map. And information sharing. Make sure that you have a way to share information easily, like I mentioned before, like a wiki tool, or somewhere where you're managing your projects and your tasks. This is the Women Who Code Tokyo Notion workspace. Isn't it beautiful? Almost like we're running a company. So we have like a wiki-like resource management on the side, where we can find the design resources, the text templates, anything, the list of sponsors, branding guidelines, everything is there. And then we have also our tasks organized in kind of a Kanban board, where we throw ideas, we change the status, we assign people. It's very easy to manage. And last but not least, team building. Because we were talking about people, we're talking about humans, and the best way to improve your productivity and the environment on your teams is to have them have a good relationship and be willing to work together. So knowledge sharing, if you can encourage knowledge sharing among your team, like a session. Like on my team, we have a bi-weekly Learning Friday. So every Friday we order lunch, and then we go into a meeting room and someone teaches something to each other. It's a very cool practice. We also have company-wide lunch and learns for whoever wants to join. It's a nice way to share information. You gotta have them communicate very often. Have your daily stand-ups, have them communicate through Slack. Just make sure your team is communicating a lot and have them feel like a team. So they want to help each other and not screw each other, hopefully. Yeah, so this is basically the checklist that we went through. And you have to tackle several different areas to achieve productivity and scale your business, scale your projects. It's not a one silver bullet. So that's basically it. Thank you for your time, and if you want to get in contact, here's my contact information. Thank you. Questions? How do we do that? Do we pass the mic?
Yeah, those are really great pointers. Do you have any suggestions on improving multilingual office? I know that are not native English speakers. And sometimes at different places I've worked, talking about code and having an intense discussion, and then there's a second level of that. Yeah. Do you have any tips?
Of course, it depends on the level of language of the people that are involved. If you have people on very different levels of language, the way that we do at Mercari, you have interpreters. Actually, yes. Because we do have big language gaps sometimes, so we need interpreters to come to our meetings. And we make sure that before the meeting, we know that we need an interpreter or not.
Wow.
But if the level is a little bit closer, then it's more about empathy.
Yeah.
It's a lot more about really try to understand what the person is saying and try to be understood as well. So we actually have a communication training inside Mercari that's called Yasashi Nihongo, which translates into gentle Japanese or easy Japanese. And also we have the easy English to help people to speak in a very clear and simple way to be understood by each other. So those are good initiatives to have.
Cool. Oh, that's on NHK. I'm gonna look it up. Thank you.
Any other questions?
Thank you for presentation. And I also agree that team building make a very more good team relation with members.
Mm-hmm.
But I work together with you. I work at Mercari, same company. It becomes a very good big organization.
Mm-hmm.
And I found some teams very good communication with members, but some of them very lack of communication. Finally, so they are lack of the result. The team cannot make a good output. So I want to suggest them why don't you have a communication kind of lunch and learn or kind of tea break time. I don't know, but such kind of suggestion I want to suggest. But some of them said well, sorry, we don't have a time, we are busy. So, and they don't notice how important it is. They only focus on the tech skill or the deadline. Not only focus on communication, but I also think communication is very important. So, but how do you suggest that case?
Yeah, I know exactly. And I think it's on the company culture. We should put even more emphasis on communication. And I also think it's kind of a management job as well. Me as a manager of a team, I want my team to communicate well. I understand how communication is important. So I will go and tell everyone we need this time for communication, or we need this time for team building to improve our relationships. A lot of people think of team building as party on the company expense. It's definitely not. I mean, sometimes. But the most important part is the relationship that you're building. Because when you start trusting each other, the communication improves a lot. You're not afraid of saying your honest opinion to each other. So the team relationship improves and your results improves. So I do think managers should encourage that if they are in this position, and of course make the members understand that communication is really, really important. Any other questions?
Hi, thanks a lot for this presentation. Just out of curiosity, you presented some tools. Was it a choice? Did you went through a POC or things like that to choose those specific tools?
I think depending on what you're using, there's a tool that is more popular for that. And so, for example, if you go with, let's say, GitHub, then Circle CI is very, very popular to integrate with GitHub, right? But I think, when I choose a tool, I usually look at the ones that are really popular across the globe. And I try if it fulfills the main goals that I'm trying to solve. So if I'm trying to solve like automation, or if I'm trying to solve incident handling, I'm going to go with the tool that better solves that. And not every time you're going to have like one tool that fits all, that solves all the problems. So sometimes you have to mix and match. But yeah, I usually look at the most popular ones. Sometimes if you have very specific local problems to your region, you can look into like local tools from your region. There are some tools made in Japan that are good for, I don't know, problems that we have there. So yeah. Any other questions? Okay, I think we're good. Thank you. Oh, thank you. Oh my God, this is so sweet.
There's still time, so you can go have a break for a while and go back here at 4:30.
Oh, thank you. Thank you.
That's so cute.
Yes, nice.
And I have a pin.
Oh, speaker.
Speaker.
Nice, nice, nice.
Kawaii.
Lion.